Chapter 7, Review. Number 1, find the function value indicated for the function. If necessary, round to 2 decimal places. If the function value is not a real number and does not exist, state so. So the last part of that instructions has to do with, remember that if we get a negative under our square root, we have to say that's not real. So we want to find c of negative 4. So everywhere that x is, we need to put in a negative 4. Now you might say, oh no, that's a negative under the square root, but remember our order of operations. First we need to add those two numbers together. Negative 4 plus 13 is 9. So that's okay. We can take the square root of 9 and we would get 3. That would be our answer. Find the domain of the square root function. So remember, domain has to do with what values of x we're allowed to plug into a function. And a lot of times we're allowed to plug in any number we want into a function and we'll get an answer. But for square roots, we know that if we have a negative underneath our square root, that's not a real number. So what we want to do on this problem is we want to take what's underneath the square root. We want to say that has to be greater than or equal to 0. Okay, the only thing it can't be is negative, which is less than 0. It can be 0 and it can be bigger than 0. Then we're going to solve this inequality. So add 18 to both sides, which gives you 3x is greater than or equal to 18. Divide by 3 on both sides, and get x is greater than or equal to 6. Then this is multiple choice, so we want to match that. That gives us an answer of A. We're evaluating another function value. This time we have a 3 here. Remember that this is the cubed root now, which is a little bit different than the square root. It's kind of completely different, but it's also similar. Depends on your perspective. But we want to put 21 where x is, and then underneath our cube root, that's addition that we can do. 21 plus 6 is 27. Remember, the cube root means what 3 numbers can I multiply together to get what's under the radical sign, where all of them are the same. So if you don't know the cube root of 27, you can type that in on your calculator, or you can make a factor tree or use the cake method that we talked about in class. If I make a factor tree, I see that I have 3 3's. So that means that the cube root of 27 is 3. Number 4 says find the indicated root or state that the expression is not a real number. The way you know if it's going to be a real number or not is if it's an even root, okay, which means this number that's on the outside, if that's an even number and you have a negative, that means it's not real. But if you have an odd root, so that number on the outside, if it's odd, then it's a negative of whatever the square root of that, or cube root or whatever of that number. Okay, it basically means if it's an odd root, like if this was the 5th root of negative 1, well, it makes our answer negative. Our answer to that would be negative 1. But the 10th root of negative 1 is not real, because it's an even root. So it's like how a square root, we can't have a negative underneath. Use radical notation to rewrite the expression. Simplify if possible. So when we see this exponent of 1/4, the top number is the power that's happening, and the bottom number is the root that's happening. And so normally when we talk about square roots, which would have a 2 on the bottom, this is a 4 on the bottom, so that's going to give us the 4th root of xy. And then this 1, we could put parentheses here and put a 1, but remember, if we have something to the first power, we don't actually really have to write that. So this is our answer to this problem. Rewrite the expression with a rational exponent. So we're going backwards this time. Remember, the top number of our rational exponent, our fraction exponent, is the power, which is 9. Sorry. And the bottom number is our root. This is a square root, so there is a 2 on the bottom. Okay, so this number right here, whatever's there, is what goes on the bottom. The power right there goes on top. Rewrite the expression with a positive rational exponent. Simplify if possible. So the way, whenever we talked about exponents a whole bunch, the way we did this is if it has a negative exponent, that means move it down to the bottom. Since that was the only thing we had, that puts a 1 on top, and on the bottom, that gives us 9 to the positive 1/2. The act of moving that down to the bottom is what made our exponent change from negative to positive, which is what we wanted to have happen. It tells us to simplify if possible, so 9 to the 1/2 power. The 1/2 power is the square root. We know what the square root of 9 is, so this is just 1/3. Use rational exponents to simplify the radical. If rational exponents appear after simplifying, write the answer in radical notation. So remember that for our rational exponent we put power, which is 8, over root, which is 12. But 8 over 12 is a fraction that we can simplify. We can divide both those numbers by 2, but we can also divide them both by 4, so that would be the better way to go. Okay, if you divide it by 2, you just end up having to simplify again. Okay, so this is what it is simplified, and since we still have a rational exponent, we want to rewrite this back the way we started, where we have a radical. So now the root is 3, because the bottom number is 3 now, and inside we put a 2 for the power. Simplify by factoring. So we basically need to take each part of this and look at it separately. And remember, if it's the cube root, we're looking for sets of 3. Square root, you're looking for pairs of number, but here we want trios. So we need to start off with a factor tree for 81, which 81 is 9 times 9. 9 is 3 times 3. We have a trio of 3's, which is going to put a 3 on the outside of our cube root. But we also have a 3 left over here that needs to go on the inside. The x and y's are a little trickier maybe. I think the easiest thing to do is to write out x 8 times. Which maybe is frustrating to do, but now it's really easy to see. We're looking for sets of 3. So here's a set of 3, and here's a set of 3. Which means that for each set, one thing goes outside. So for each set of 3, we put an x on the outside, which means that on the outside will be x squared. And on the inside, we put what's left over, which is x times x, which is also x squared. Y to the 6, we're going to do the same way. We're going to write out y 6 times. And we're going to say there's a trio here, which puts a y on the outside. There's a trio here, which puts a y on the outside. So on the outside, we have y squared. On the inside, we don't actually have any y's because there were no y's left over. Now, be careful whenever you write this and try to make sure that you can see the difference between this is 3x squared y squared and then the cube root of 3x squared. The way I had it written there first, the 2 and the 3 kind of ran together. So be careful, because things like that can get you if you're not clear about what you mean on your answer. Number 10 says multiply and simplify. Technically, we could simplify first and then multiply, but to me, I would rather just have to simplify once. So I'm going to do what the instructions say and multiply first, then simplify. So if I multiply these square roots together, everything that I have, the numbers and the x's are inside, so I'm allowed to put them under the same square root as 20 times 4, which is 80, and x times x, which is x squared. So now I need to simplify this. 80, I need a factor tree for. So I have, since it's a square root, I'm looking for pairs of numbers. So here's a pair, here's a pair. So I have 2 2's on the outside, which is 4. And then I have just a 5 left over on the inside. Then I look at x squared. X squared is x times x. I'm looking for pairs. So I have a pair of x's, which brings out an x. I don't have anything left over to go on the inside, so my answer is 4x square roots of 5. On number 11, we want to add or subtract as indicated. So the way this works for radicals is you're only allowed to add things together that have the same square root, or whatever kind of root it is. And what I mean by that is that 7 square roots of 13 and negative 6 square roots of 13, those are like terms. So we can do 7 minus 6 and get 1 square root of 13. Then 5 square root of 6 and negative 8 square root of 6 are like terms. If we add those together, we get negative 3 square root of 6. We cannot add these together. This is our answer. The square root of 13 and the square root of 6, there's no way to put those together. Use the quotient rule to simplify. The quotient rule they're referring to is the fact that we can split this up into 2 separate square roots. And the times when it's helpful to do that is when either on the top or the bottom we have something that we actually can take the square root of. Now, on the top, we can't take the square root of 30, but on the bottom, the square root of x to the 4th is x squared. Because x to the 4th is 4x's, it's got 2 pairs of x's, so the square root of x to the 4th is x squared. And the whole thing behind this is that we, as mathematicians, generally don't want square roots on the bottom of our fractions, and so we just achieved that. We got rid of the square root on the bottom. This says divide and, if possible, simplify. Again, we want to pay attention to the instructions because we could simplify first, but if we divide first, it actually makes it easier. So if I divide, that means I'm basically writing this all as one fraction underneath my square root. And I need to do 6 divided by 2, which is 3. X divided by x cancels out. Y cubed has nothing to divide with, so it stays y cubed. Now let me simplify. Well, I can't take the square root of 3 and I can't simplify the square root of 3, but y cubed I can think of as y times y times y. So this is a pair of y's, so y goes on the outside. And then on the inside, the 3 is there, and then there's also a leftover y. So this is y square roots of 3y. Multiply and simplify. So we need to distribute. So 7 times 5 is 35. And distribute to the second thing. 7 times 3 is 21. And that's a negative in front because this is a minus sign. Check and see if this will simplify. That one doesn't. That one doesn't. So that means that this is square root of 35 minus square root of 21. Now we can't just distribute here, we have to FOIL, and so if we start off, first is 4 times 2, which is 8. Outer, remember that this is 4 times 3 square roots of 6, and the way this works is you're allowed to multiply numbers outside the square root together, or if two things are inside of the square root, you can multiply those together. So this would be 12 square roots of 6. You don't mess with the 6 because there wasn't anything for it to multiply with. Inner, square root of 6 times 2, well, again, we have a situation where we have something inside, something outside. Those don't actually multiply together, we just write them next to each other, 2 square roots of 6. And last, now this one's the tough part, so square root of 6 times 3 square roots of 6. That 3 has nothing to multiply with, so that needs to be in there. The square root of 6 times the square root of 6 is the square root of 36. Or you may have realized, because of some other problems we've done, the square root of 6 times the square root of 6 is 6. And so we actually can put 6 here instead. That means that we're doing 3 times 6, which gives us 18. So 8 plus 12 square roots of 6 plus 2 square roots of 6 plus 18. Now we're ready to add like terms. The numbers that don't have a radical will go together. 8 plus 18 is 26. The numbers with our radicals, 12 plus 2 is 14 square roots of 6. And that's our answer. We can't add those together because one has a square root and one does not. Rationalize the denominator and simplify. So there's been other problems that have had fractions where we could have tried to rationalize, but you don't need to worry about doing that. There's easier ways to do the other ones. It's on this problem where it actually says rationalize, and the next one where it says rationalize that we really do have to rationalize. So we need to multiply the top and the bottom of this fraction by square root of 3x. So that we get 4 times the square root of 3x, which is 4 square roots of 3x. And square root of 3x times the square root of 3x is the square root of 9x squared. Or you might have realized from either of these steps, the square root of 3x times the square root of 3x is 3x. If you don't believe me, look at this. Square root of 9x squared, well, the square root of 9 is 3. The square root of x squared is x. Now, this does not simplify anymore. We can't mark out the 3's and the x's because they aren't really in the same realm of things. Like the square root of 3x, that square root is protecting that so that it can only cancel out with stuff that's inside of a square root. If there was something outside that was the same, like if it was 6 over 3, then yeah, we could simplify, but we can't simplify with these numbers the way they are. Now, when we rationalize the denominator and there's more than one thing on the denominator, what you have to do is multiply the top and the bottom by the bottom where we change the sign in front of the square root. So, on top, that means that we're foiling. Square root of 7 times negative square root of 13 is a negative square root of 91. Square root of 7 times 2 is 2 square roots of 7. On the bottom we have to FOIL, so square root of 13 times negative square root of 13 is negative square root of 169. Square root of 13 times 2 is 2 square roots of 13. 2 times negative square root of 13 is negative 2 square roots of 13. And then 2 times 2 is 4. Now we're ready to see what we can simplify. On top, there's really nothing we can do. It's just going to end up being negative square root of 91 plus 2 square roots of 7. And that has to do with the fact that if we try to make a factor tree for 91, the only things that multiply to get 91 are 7 and 13, so there's no pairs or anything like that. On the bottom, something neat happens. These two things cancel out. The square root of 169 is actually 13, which should make sense because we had the square root of 13 times the square root of 13, which is 13. So on bottom here, we have negative 13 plus 4, which we can actually work out what that is. Negative 13 plus 4 is negative 9. And so this might, if this was multiple choice, for instance, this might be the answer, or they might decide to change all the signs. If you want to, in a math problem like this, as long as you change all the signs, you end up being okay. So that would make this positive square root of 91 minus 2 square roots of 7 over positive 9. And generally speaking, most mathematicians would prefer that answer over this one. But so if it's multiple choice, keep that in mind. Let's solve some equations. The thing is that we want the square root to be by itself, and when it is, we square both sides of our equation, and that gets rid of the square root. Leaves us with 8x minus 7 on the left side and 7 squared on the right side, which gives us 49. So now we're ready to just solve for x. We add 7 to both sides. Divide by 8. So x equals 7 is our answer. This one's trickier because when we square both sides, we need to think of this as we're squaring the whole side. We don't square things individually. We're squaring this entire side. So on the left side, it leaves us with x squared minus 3x plus 64. On the right side, x plus 5, if you square it, you have to think of that as x plus 5 times x plus 5, which means you have to FOIL. X times x is x squared. X times 5 is 5x, so is 5 times x. So I can add those together and get 10x. And then 5 times 5 is 25. So we need to solve this. Because we have x squareds, the first thing we should do is try to get the x squareds on the same side. And then we see that if we subtract by x squared to try to move one of them, they both actually cancel out, which is great. That's an ideal situation. So now we just need to get the x's on one side and the numbers on the other. I can add 3x or subtract 10, whichever way I want to go about that. And I can, since I added 3x, I need to subtract 25. So this is 39 equals 13x. And if you divide both of these by 13, then you get x equals 3. Number 20, 5 minus the square root of negative 80, it asks us to write in terms of I. So this is where instead of it being an issue that there's negative under the square root, we do something about it. The first thing we want to do is take that negative out of the square root by putting an I in its place. So we have 5 minus I square roots of 80. Then we want to take 80 and see if we can simplify it. So we make a factor tree or a cake for the cake method. And we see that we've got 2 pairs of 2's since we're doing the square root. So that means that I need to have 2 2's on the outside, which gives me 4. That'll go right in front of I. Then we have a 5 left over, which will go on the inside. Perform the indicated operation, write the result in the form a plus bi. The indicated operation here is addition, which means that we need to add these together, and we add these together with like terms. So that means I have 6 plus 8, which is 14, and negative 9i plus 2i, which is negative 7i. And that's all I can do because that's all of my like terms. Number 22, we are going to subtract, which means that we have to change the signs in the parentheses after the negative, the way we've been subtracting the whole time that we've been in this class. So when we do that, it changes it to an addition problem. So a negative 3 is a positive 3, negative I is negative I. Then it's like what we did on 21 where we add like terms. So 7 plus 3 is 10, 3i minus I is 2i. So our answer is 10 plus 2i. This says find each product. Product, remember, means multiply, so we're going to distribute. 5i times 2 is 10i. And when we're multiplying like this, we treat I just like we would an x. So 5i times negative 2i squared is negative 10. Sorry, I said that wrong. 5i times negative 2i is negative 10i squared. So one of the things that we know that we have to remember, because this says write in the form a plus bi, I squared we can change whenever we see it to negative 1. So this is 10i minus 10. Where I squared is, I'm going to write negative 1. So I need to multiply together negative 10 times negative 1. And I get positive 10 plus 10i. And technically that's a better answer than if you had written it 10i plus 10. It asks us to write it in this form and look at the order. The I comes second, not first. So this right here is our best answer for that. 24, we want to FOIL. So 9 times 5 is 45. 9 times 5i is 45i. Negative 7i times 5 is negative 35i. And negative 7i times 5i is negative 35i squared. So in the middle we have like terms. That's going to be 10i, 45 minus 35. So we have 45 plus 10i minus 35. Where I squared is, we put in negative 1. So negative 35 times negative 1 gives us positive 35. So we add together 45 and 35 to get 80 plus 10i. Divide and simplify. So dividing for complex numbers seems kind of weird. What we do is we take what's on the bottom, 7 minus 2i. We change what's the sign that's in front of I, which means we times by 7 plus 2i. So this doesn't really seem like division because we're multiplying, but that's how we do it. All we're trying to do really is get the I off the bottom of the fraction. So on top we FOIL. So 5 times 7 is 35. 5 times 2i is 10i. 6i times 7 is 42i. And 6i times 2i is 12i squared. We will simplify that in a moment. On bottom, 7 times 7 is 49. 7 times 2i is 14i. Negative 2i times 7 is negative 14i. Negative 2i times 2i is negative 4i squared. So now we're ready to start simplifying. The bottom is pretty easy because those two middle terms cancel out. Then we have 49 minus 4 times negative 1 if we change the I squared. And that gives us 49 plus 4. Negative 4 times negative 1 is a positive, which means on the bottom we have 53. On the top we have like terms in the middle. So we can change 10i plus 42i to 52i. And then we can say that's plus 12 times negative 1, because we put a negative 1 where the I squared is. So 12 times negative 1 is minus 12. 35 minus 12 is 23. Now this is our answer because we can't simplify, or the way if it was multiple choice it might be written is they might split this up into two different fractions. So what you do is you just put the 53 underneath each of these two numbers with the I next to the number that has an I. So that might be what you see as an answer choice.